Hi everyone, and welcome to lesson 4 of our Unit 4, Quadratic Relations. And today we're going to learn how to expand a quadratic from the factored form to the general form. So again, we've been working with quadratics now for a few lessons, and we started by working with the general form of them, where we had something like this. We had ax squared plus bx plus c. And we recognized that it was different than what we used in grade 9, different than a linear, because of the squared on this first x term. And so we started the first few lessons working with that. And then last lesson, we introduced the idea of the factored form. And so this is the general form of it, x minus r, x minus s. So we had these two brackets. So we called this the general form of the quadratic, and this was the factored form of the quadratic. So we introduced these two ideas. Just so you can see a real example, it would look something like this. Y is equal to, 2x squared minus 3x plus 7. So that's a general, that's a parabola. Both of these, by the way, are parabolas. So both of these are, if you want to think about them, they're going to be a graph with a U-shaped. I don't know where that U-shaped is. I don't know. You're going to learn more about where where they are. But it's down here somewhere, or maybe even it's facing down. Now, we know that it's not this last one. Based on our last lesson, because if it was facing down, this first A would be negative, and so I know that it's actually not that one, but I don't really know where it is, where this parabola is right now. Okay, so the other one we learned about as well was this factored form of a parabola. So it might look something like this, negative 7x minus 3x plus 2. So that's this is a factored form of a parabola. And again, we know that it's, the fact that it has this form, we know that it's a parabola. So it could be over here, it could be down here, it could be here. And we know that it's facing down. We know that because the A is negative. Okay, so that's kind of a general review. But what we're going to learn about today is how can you go from the factored form to the general form. So, just like with, just like with linear equations, we can go from y equals mx plus b form to the general form. We said it was, ax plus by plus c equals 0. You can move back and forth between those. Well, you want to be able to do the same thing with quadratics. And again, just kind of an example of this, I think we more often would have gone from this form to this form because we wanted to see the slope in the y-intercept. So if we had something like this, 2x plus 4y minus 7 equals 0, we could quickly change it by moving. We'd subtract the 2x from this side, add the 7. Well, whatever you do to one side of math, you got to do to the other. And then we would have 4y is equal to negative 2x plus 7, and then divide everything by 4. And so in that situation, we have y is equal to negative 1/2 x plus 7 over 4, which is 1 3/4, or we could just leave it as 7 over 4. So we know that that's the y-intercept, and we know that that's the slope. Okay, so that's where we're headed, is we want to be able to move back and forth between these two forms. And so today we're going to learn how to go from factored form to general form. We're learning that move. And what it's called is, what we'll call expanding a quadratic. So that's kind of where we're heading. I'm just going to move this down so it's together. Okay, so here we go. So the question we're going to start with an example here. It says, show that these two equations represent the same quadratic relation. So, they don't look the same right now, and I'm not convinced of that, but we want to show that these two are the same. Okay, so what I want to try to prove to you is, using our expansion, is that this can be changed to that one. Okay, so here we go. I'm going to rewrite it down here. Y is equal to x plus 4, x plus 2. And what we're going to do is we're going to use the distributive law. We're going to use the distributive law. Okay, and so with the distributive law, a lot of you have seen distributive, you've heard me talk about it before, and so it's something like this. You'd go, well, Mr. Webster, I've seen it where you go, I don't know, 2 times x plus 3. So you go this times this, and this times this, and you get 2x plus 6. That's distributive. Or maybe even something a little bit more complicated if it was 2x times x minus 3. So you'd go that times that. Well, 2x times x is just 2x squared, because you have to add the exponents. And then 2x times minus 3 is minus 6x. You multiply the numbers and then just bring along the variable. So there we go. So you've seen this before in grade 9. And we're just going to use something similar. So here we go. The only thing that's a little bit different when you have two brackets is that you have to do something called FOIL. Okay, and what FOIL is it's first, outer, inner, and last. First, outer, inner, and last. So here we go. Let's do the F first. So F is we do the first things in the brackets. So x times x, remember we just talked about that, is going to be x squared. So you add their exponents, so it turns into x squared. Okay, O. Here I'm going to do a different color here. I'm going to go with green. Okay, outer. So I'm going to do the two outer ones in the bracket. So x is the outside of this one, and 2 is the outside of this one. So x times 2 is just 2x. Okay. Inner. So here we go. We're going to do that times that. So plus 4 times plus x is plus 4x. And finally, last, it's the 4 and the 2 are last, so 2 times 4 is 8. Okay, so that is FOIL, first, outer, inner, last. But before we're done with this, we want to collect like terms. So look at this. Notice that those both have an x, so we need to collect like terms. And they're like because they both have an x with an exponent of 1. So our final answer is x squared plus 6x plus 8. And sure enough, it's the same as the other one. So those two parabolas are identical. They're going to yield the same curve, the same U-shaped. It doesn't matter which one we do, it's the same thing. So just like with lines, just like this equation and this equation are the same line, so are those two the same parabola. Okay, let's do another couple of examples of this. So here we go. Expand and simplify. You're going to have to do some of these for homework. All right, so here we go. First, 2x times x. Well, that's 2x squared. So first, outer, 2x times negative 2 is negative 4x. Inner, plus 3 times x is plus 3x. And last, plus 3 times negative 2 is negative 6. combine your like terms. So negative 4x plus 3x is negative x minus 6. Well, sometimes you have a number out front. We've seen that, like that's what we call the a. So let's leave that till the very end. So what I want you to think about is let's do, I know that this square bracket wasn't there before. I've kind of added that in, but I want to just work on my FOIL first, and then I'm going to do the whole, then I'll multiply 3 times everything. So here we go. Let's do our first. 2x times x is 2x squared. Outer, 2x times negative 3 is negative 6x. Inner, negative 1 times x is negative x. And negative 1 times negative 3 is plus 3. Okay, so here we go. Let's collect our like terms. Negative 6x minus another x is minus 7x. Plus 3, okay, and then finally now we'll use kind of the distributive that you guys have seen in grade 9, which is we can now take the 3 throughout. So 3 times 2x squared is 6x squared, 3 times negative 7x is negative 21x, and 3 times 3 is 9. So that's just if there were a number out front. There are other ways of handling that number out front, but I think this is the easiest. Okay. Let's do one more example here. It says connecting the factored form and the standard form. So this is really what I talked about right at the beginning of the lesson, is let's connect these. And so this says determine the equation of the parabola and express your answer in standard form. So this is kind of a really good one. So you've been given this U-shaped parabola. So you feel pretty good that this is, you know, this is a quadratic. And so you know it's something that looks like ax squared plus bx plus c, or you also know that, you know, that's the standard form, but you also know that it could be a x minus r x minus s. So those are the standard forms, the standard general form and the standard factored form. So the key is to be able to pull the information off the graph, and they want you to give the equation of it. You know, again, just like in grade 9, I would have given you a graph like this, and I would have put a line on it, something like this. And here, let's put a couple of, we'll say that this was plus 1, and this was plus 2 right here, and we'll say that this was negative 1 and this was negative 2. And so I would have said, what's the equation of that line? And you would have looked at it and you would have said, okay, well, I know that its y-intercept is 2, so I know that the b is equal to 2 in y equals mx plus b. So you would have said, hey, I've got off to a good start. It's mx plus 2, and then you would have said, well, I also know the slope, because you look at this, you rise 2 and run 2. So you would have said, well, the slope of this is it's rise over run, and you would have said, okay, well, I rose 2 and I ran 2. Oh, so my slope is 1. And so you would have come back and said to me, it's 1x plus 2, or just y is equal to x plus 2. That's what we did in grade 9. Well, here in grade 10, we're going to look at this and do the same thing. Well, that means I'm going to have to get, you know, either the a, the b, and the c, or if I got the a, the r, and the s, either one of those is fine. And I think what I'm going to show you is that this one, if you're going from a graph, this is the one to go to. Now, once we get it in factored form, it's easy to expand it and change it into the general or the standard form. Okay, so let me show you how we can do this. So first of all, when you look at the graph, this r and s, the r and the s are the x-intercepts. So, you know, those are really important here. So I look over at my graph and I can see that I've got an x-intercept at -4 and at 2. So look at this. I know that my r is equal to -4, and I know my s is equal to 2. That's kind of cool. Okay, well then let's plug those in. And so here we go. Let's go grab our equation. So y is equal to a times x minus, now watch this. Notice that the minus sign is there, so then I would put in -r, or -4, and then I'd go, and then x minus 2. Oh, okay, so I got it. Let's just fix that up because I don't like having that double negative there. And so I'll go a times x plus 4, x minus 2. Okay, so that's cool. I've used my two x-intercepts to get this far. But what's the a? Well, remember what we said is that, we did this at the end of last lesson, is if I could just sub a point in there, then I could get my a. Just like in grade 9, we could sub a point in to get our b. Well, I can quickly see that this point right here, which is 0, 4, is a point. I can't, some of you may say, well, why wouldn't you just sub in your x-intercepts? Unfortunately, you can't use those at this stage. You have to use a different point. And so that's why we'll pick that point. So we're going to sub 0, 4 in to get a. Okay, here we go. So let's sub that in. So I'm going to sub in an x of 0 and a y of 4. So 4 is equal to a. 0 plus 4, 0 minus 2. Okay, so here we go here. So 4 is equal to a times 4 times -2. So 4 is equal to, well, 4 times -2 is -8, so -8a. And then to get rid of the -8, we divide both sides by -8, and we get a is -1/2. Awesome. So basically, here's what we know about this equation. We know that y is equal to, there's the a, -1/2 times x plus 4, and then oops, I said 4 and I wrote 2. X plus 4, x minus 2. And now the question did say they wanted it in expanded form, so or the standard form. So here we go. Let's leave the -1/2 for now. First, x times x is x squared. First, outer, x times -2 is -2x. Inner, 4 times x is plus 4x, and then last, plus 4 times -2, -8. Okay, collect like terms is x squared plus 2x minus 8. And then finally take the negative in, so -1/2 x squared, so we do it times the first, times the second, times the third, and you get minus x plus 4. -1/2, a negative times a negative is a positive, and a half of 8 is 4. So there you go. There's your final answer, is -1/2 y is equal to -1/2 x squared minus x plus 4. So we've been able to write the quadratic in both forms. Okay, we've got it in its factored form, and we've got it in its standard form. Okay, so here's your homework. I've circled them here. These ones are examples. I wanted to just show you a couple quick things that you might come across. Notice that first of all, they don't have to use x. So look at this one right here. I'm going to go down to 7 just for a second here. I'll use a different color. So this one, they've used a. So whether or not they use x, it doesn't matter. So, and in this one, they've only got one bracket, but the squared outside. So technically what that means is a plus 4 times a plus 4. So if you ever see a squared, it just means the bracket is repeated. And so in that case, no, I can FOIL this one now. It's just going to be a squared plus 4a plus 4a plus 16. Okay, and then I collect my like terms, and it's a squared plus 8a plus 16. So don't be afraid if it shows a bracket. I just wanted to show you that one. More of your homework here. There's a good example where they have the number out front, and you know how to do that. Okay, and then number 11, it says write the equation. Okay, so this is exactly what we did in that last example, so you'll do 2 of those. And there are the answers. All right, you guys, so good luck with that. Let me know if you have any problems.